right, so we're going to go through the remaining multiple choice problems on this review, and let's start with problem A. Peer relationships are an important part of the socialization process of children and require the use of many complex social skills. Substantial evidence suggests that children with poor peer relationships are more likely to be truant, repeat grade levels, and drop out of school. In a random sample of 15 fifth grade students, peer acceptance as measured on a sociometric scale showed a mean of 2.72 with a standard deviation of 0.15. Which of the following gives a 90% confidence interval for the mean peer acceptance of all fifth grade students? So we're looking for a confidence interval, and this is on the front page of your formula chart that you get to use on the AP exam. Confidence interval is your statistic plus or minus your critical value times the standard error for the statistic. So I'll go ahead and get started with a critical value, which we're going to calculate using inverse t. Why are we using inverse t? Because we're dealing with means and not proportions. Okay, so to find the critical value on the TI-84 second distribution, inverse t, remember inverse is for critical values. We're doing the t distribution because we're working with means. We want a 90% confidence interval, but we have to make an adjustment because this is only left area, and we add in the left side of the interval, what's to the left of it. We have a sample size of 15, so we subtract, not 4, subtract 1 to get our degrees of freedom, so it'd be 14 degrees of freedom, hit paste, and we get 1.761. So now that we have 1.761 right there, we're going to go ahead and also look at the mean. If you look at the mean, it says it's 2.72, which is the same for all of these. So the mean's not really going to help us eliminate any choices, but we can eliminate 3 of the choices because only 2 of these have the same critical value. So now we only have to look at the standard error, the sample statistic. Again, this is straight off your math chart. And we have our S, standard deviation of 0.15, and we have our sample size of 15. So our standard error for our statistic is 0.15 over square root of 15, which is choice E. Number 9, a company has 1,000 employees evenly distributed throughout 5 assembly plants. A sample of 30 employees is to be chosen as follows. Each of the 5 managers will be asked to place the 200 time cards of their respective employees into a bag, shake them up, and randomly draw out 6 names. The 6 names from each plant will be put together to make up the sample. Will this method result in a simple random sample of the 1,000 employees? So we've seen this question a lot. Remember, the definition of a simple random sample is that every group of size n has an equal chance. In this case, it would be a group of size 30. So definitely remember this. And just in case you're wondering what kind of sample they took a stratified sample. So the correct answer is no, because not every group of 30 employees has the same chance of being selected. Number 10, given that the probability of E is 0.32, the probability of F is 0.15, and the probability of E and F both happening is 0.048, which of the following is a correct conclusion? Well, E and F are mutually exclusive if the probability of both of them happening is 0. But they just told us that it is 0.048, which is not 0, all right? So that means it's not mutually exclusive. So you can cross off A and you can cross off C, all right? Then let's go ahead and look at independence. They're independent if the probability of E and F is the same as saying probability of E times probability of F. So here's E and F, the 0.048 from above. Probability of E is 0.32, probability of F is 0.15. Multiplying them together, we get the same number. So they are independent, and the correct answer is D. Number 11, the number of leasable square feet of office space available in a city on any given day has a roughly normal distribution with a mean of 640,000 square feet and standard deviation of 18,000 square feet. What is the interquartile range for this distribution? Remember, IQR is Q3 minus Q1. Q3 is at the 70th percentile. So you can do inverse norm, area, 0.75 on the left. The mean is 640,000. Standard deviation is 18,000, and we're specifying the left area. So on our calculator, we'll do this. Actually, let me show you the old calculator. We're going to find Q3. All right. Second distribution, inverse norm, right? And so the area is 640,000. I did not like that comma, by the way. One more. And our sigma is 18,000, and we're doing left-sided area. And we get a value of 652,140. Now, here's a cool trick to get both Q3 and Q1. What you can do, those are defined to be the middle 50%. So instead of focusing on the left area, let's say you have one of the newer calculators that can do the center, just do center instead of left, and you'll get both values, because that's what Q1 and Q3 cut off, is the middle 50%. So those smaller values, 627,859, kind of close to 628,000 for this case, and the higher value is 652,000. Actually, so there's 652,000, and again, we can get both by doing a center area. Remember to change the area to 0.5, because the IQR is the cutoff for the middle area right there. And then our mean, standard deviation, and make sure you say center. So that gives us that rough interval right there, which matches choice A, because it says what is the range, so we would take the higher value minus the lower value. Number 12, considering the following back-to-back stem plot, which of the following is a correct statement? The distributions have the same mean, the distributions have the same median, the IQR to the left is 20 greater than the IQR to the right, the distributions have the same variance, and then none of the above is correct. So the means and medians are definitely different for both distributions, because you can see that the one on the left has higher values than the one on the right. And that would affect both the mean and the median. Now, to calculate IQR and the variance, it's probably easier to enter the data into the calculator. So I went ahead and I already entered the data in lists. So again, you're working backwards. So that first row on the left is 23, then 24, then 28. So when you have back-to-back stem plots, the left side is written sort of backwards or mirror image. The numbers in the columns are your tens place, that's how it's defined. And you can see, if you read the key, it does tell you how to read it. So anyways, we have all the data entered here. So I'm just going to go hit Stat Calc. We'll do one var stats. So for list 1, my mean is 54.8. And you can actually go down. Here's my standard deviation, 25.03. And here we have our median is 52. So let's go ahead and look at the one for the other set of data. So I'll do list 2 and calculate. And you can see here we have the 25.03. The mean is different this time. So is the median. All right. And the IQRs, they're probably, we could go ahead and calculate those with the summary stat. So one cool thing you can also do is you can go Stat Calc. And you can actually say 2 variable stats. So this is nice if you're trying to do 2 lists at once. So I'll put list 1 in my X list. It doesn't really matter that it's X and Y. It's just how it's going to list it. It's not doing a regression. It's just calculating your stats. So it makes it a little bit easier to compare things because, like, for example, you can see that the means are 20 apart. So those are 20 apart. That the standard deviations are identical, right? And then I guess the disadvantage of this is it doesn't have, oh, well, there we go, min-x. Let's go ahead and pull these up. It doesn't have the Q1 and Q3, so that is a disadvantage. So let's go ahead and run one of our stats so we can get Q1 and Q3. Our 5-number summary. There's Q1, 31.5. Q3 is 82.5. So that would be an IQR of 51. Let's go ahead and run one of our stats for Y. So remember that was 51 for IQR. Change this to list 2. And now we get our 5-number summary, and you can see these two are 51 apart, so they have the same IQR. One is not greater than the other. So the only one that is correct is that the distributions have the same variance. Why? Because they have the same standard deviation. So again, here are our list 5-number summaries for both lists. And there's the IQR calculation right there. And then we have list 2, and you can see they have identical IQRs. And as you saw, we had the exact same standard deviation. And remember that variance is just standard deviation squared. So they have the same variance. Number 13, which of the following is a correct statement? A study results in a 99% confidence interval estimate of 34.2 to 67.3. This means that in about 99% of all samples selected by this method, the sample means will fall between 34.2 and 67.3. Confidence intervals only tell us plausible values for the mean. It doesn't predict what other intervals will be, okay? So A is incorrect. B, a high confidence level may be obtained no matter what the sample size. That is true. You can use a 99% confidence interval. You can, but what that's going to do is just make your interval wider. All right. C, the central limit theorem is most useful when drawing samples from normally distributed populations. Actually, the central limit theorem is about non-normal populations and how our sampling distribution for means can be normally distributed if our sample size is at least 30. Choice D. The sampling distribution for a mean has a standard deviation only when n is sufficiently large. Every distribution has standard deviation. It doesn't matter what it looks like. Standard deviation can be calculated. E. The center of any confidence interval is the population parameter. If only it's basically based off of our statistic from our sample, we're trying to guess at the parameter. We don't know the parameter. So the correct answer is B. A high confidence level may be obtained no matter what the sample size. And the last one, the binomial distribution is an appropriate model for which of the following? Well, so if you look at the first one, the number of minutes in an hour for which the Dow Jones average is above its beginning average for the day. Well, none of these actually are independent. The Dow Jones average for 1 minute depends on the previous minute. B, the number of cities among the 10 largest in New York State for which the weather is cloudy for most of a given day. If we were talking Texas, we might have a little bit better of a shot here, but weather tends to be clumpy. So one city being somewhat close to another city, they're going to have the same weather. So they're not independent. C, the number of drivers wearing seatbelts if 10 consecutive drivers are stopped at a police roadblock. When you see people stopped at a police roadblock, you tend to put on your seatbelt. So it will depend on the previous driver, what goes on in terms of them being stopped. D, the number of A's a student receives in 5 college classes. If a student makes A's in one class, they're probably an A student making more A's in other classes. So none of these are appropriate for the binomial distribution because none of them are independent.